In this section, we're going to be looking at graphing polynomial functions. If p of x is a polynomial function of degree n, then the graph of the function has at most n real zeros and thus at most n x-intercepts. At most n minus 1 turning points. Turning points on a graph are called the relative maxima and minima, and these occur when the function changes from decreasing to increasing or from increasing to decreasing. So for example, if we have a cubic function like we've discussed previously, then if we look at like the graph of a cubic function, again, it usually has this drain pipe sort of look. And so what this is saying is that if we have a cubic function, degree 3, then it's going to have at most 3 zeros and at most 3 x-intercepts, as we have discussed previously. And it will have at most n minus 1 turning points. So in this particular case, we have a maximum and a minimum. And so we have this one turning point and we have this second turning point. So if it's degree 3, then it has at most 2 turning points. Now again, let's focus on the words at most, which means it doesn't have to have 3 real zeros and it doesn't have to have 2 turning points. So remember, cubic functions, for example, could look like this, where they just have a bend rather than like an actual drain pipe look. So if this is a degree 3 polynomial, well, it can have at most 3 real zeros. In this case, it would only have 1. It only has 1 x-intercept. And in this case, it doesn't have any turning points. So it could have at most 2, but it will not have more than that. So let's look at an example. So for the function f of x equals negative 4x to the 8th power plus 7x to the 5th power minus 6x plus 19, we want to state the maximum number of real zeros that the function can have, the maximum number of x-intercepts that the graph of the function can have, and the maximum number of turning points that the graph of the function can have. So if we take a look at the equation of this function, the highest exponent on a variable is 8. So the degree of this polynomial function is 8. So based on the statement that we just made from the previous sheet, the maximum number of real zeros that this function can have is 8. And that means the maximum number of x-intercepts that the graph of this function can have is 8. And so then the maximum number of turning points that the graph of the function can have is 8 minus 1, which is 7. So looking just at the degree of the function, we can tell the maximum number of real zeros, the maximum number of x-intercepts, and the maximum number of turning points, again meaning maxima or minima, that this graph can have.